Good afternoon. My name is Timur Aliyev. I am Associate Professor of the Department of Instrument Engineering of the Azerbaijan State Oil and Industry University, and we prepared a report of the topics minimization of the average risk in pattern recognition for smart grid systems. In the development of the principles of invariant pattern recognition, each object can be represented in the form XE, where E is equals 1 to n. A little letter xe is the real value of this parameter of the pattern to be recognized. From B1 to Bn are the parameters of influences of the stabilizing factor on the value xe. A standard parameter can be represented in the form YE, where little letter y is a real admissible value of this parameter of the unhealthy influences. From C1 to Cn are the parameters of the influences of the stabilizing factors on values YE. The value of the PMBP evaluated indirectly by the if parameters can be determined by the expression 1. As full invariance of parameter recognition is reached, the desired value of ZE is specified by the expression 2. To determine condition ZE equals ZE with the star, formula 1 on rearrangement can be expanded into Taylor series. Taking linear terms, we can derive the condition of the invariance of the PMBP value with respect of the stabilizing factors. This is represented in the expression 3. The uncertainty of parameter recognition can be realized as a sum of independent and correlated events characterizing the errors of measurements of parameters value of the checked and standard objects. Consequently, the certainty of parameter recognition can be determined as the product of the fiducial probabilities of parameters value measurements of the both objects. This attests that certainty in TVS will be always less than the separate fiducial probabilities of measurements of parameters x and y. To increase the certainty, it is necessary to decrease the error of the measurement of the parameters. Through the development of effective methods for the correction of measurement errors of image parameters of nature object is a real problem. Let us represent the mathematical model for the PMBP estimation in the implicit form which shown in the expression 10, where big block letter F and small letter F2 as the output signal of the measurement channel is a measurement of parameter of the object under a check and standard one, respectively. F is the function of the PMBP estimation. We can see from 10 that the stabilizing factors affect parameters x and y indically. Therefore, by minimizing those influences, we can increase the information border of PMBP value. In order to determine the extreme points, we expand 10 into Taylor series and then only consider linear terms. On some transformations, we can find the conditions of invariance of the the PMB estimation for the stabilizing factors. This is representing this expression 11. Conditions 11 show that to minimize the influences of the stabilizing factors on the PMBP value, it is necessary to minimize those influences on each parameters x and y, and the sum of the influences on the parameters should be minimal. To develop the method for minimizing the estimation errors of BMPB, we analyze the composition of the distribution laws for the measurement errors of the parameters of the recognized and reference image. Suppose the probability density Px and Py of the value of the input and the reference features of x and y have an arbitrary form, and the errors gamma x and gamma y superimposed on the values x and y are distributed according to the normal law mx and my, gamma x and gamma y. It is assumed that the errors gamma x and gamma y are correlated but independent of the value of x. If the value of the x and y differ by the value z, which equals the x minus y, and error of the first, the x more than y, and x plus gamma y less and or equal y minus z plus gamma y, and second, x less and equal y and x plus gamma x more than y minus z plus gamma y general. It is known in problem of control and recognition, each error has its own cause alpha and beta, which take on non-negative values. In this case, the average risk C will be equal to the mathematical expression of the cause, which shown in the expression 14. Where P alpha and P beta are respectively the probabilities of errors of the first and second kind. It is necessary to find the difference between the values of x and y, which corresponds to the value of the PRS output signal. For this, the composition of two normal laws of probability density with respect of the value of the variable gamma x minus gamma y equals gamma z is completed by the equation 15, where m0 equals mx minus my, and gamma 0 equals the roof from sigma x in square minus 2 rho sigma x sigma gamma plus sigma gamma in square. Using the variable gamma z, the condition for the occurrences of errors of the first and second kind can be represented as x more than x and x minus y less and equals y minus z, and x less and equal y, and x minus x more than y minus z. Considering the domains of definition of probabilities P alpha and P beta, this is represented in the expression 14. The value of the output signal should be determined by the minimum average risk. For this, differentiate the last formula and equate to 0. The solution to this equation gives the desired value of z in general form. Since the exact value of z is determined by a computational operation, we will approximately determine it. By the mean value theorem, the transform formula into the following form, we show in equation 17. The exact value of z is determined by the Simpson's method using the following algorithm is shown in the equation 25. The initial value of z is taken to be the end of the average x minimum x maximum, at which the following is performed in the equation 24. With the more simplified definition of the value of z, it is required that this condition should be met, which shown in the expression 27, where chi is the coefficient that takes into account variations of the values alpha and beta. The accept restrictions allow alpha and beta to be replaced by alpha and beta in form of 17, we get the expression 30. Approximate 30 becomes strict if f at x equals a constant. In the range of n sigma 0, or even more so in the average range of x. Then equation 30 is represented as equation 31. The form of 31 is the Laplace function are tabulated due to the fact that x maximum minus z max minus y plus z minus m0 more than the free sigma 0, and z minimum minus y plus z minus m0 more than the free sigma 0. The first Laplace function is equal to 1, and the fourth is equal to 0. Consequently, we get the equation 32. Expression 32 allows for given alpha and beta to find the number k, and which is the tabular value of the f. Hence, the output parameter z is estimation by the formula 33. With the availability of the criterion of the an either observer, alpha where alpha equals beta, the z parameters can be determined only by parameters mx and my, where z is equal to mx minus my, because if k is equal to 5 or 0 or 5, with k equals 0. Most fixed treatment of this process allow us to propose conditions for providing the invariance of the PMBP value. For random errors, sigma x equals sigma y and equals the minimum. We select that equals fxy, provided that f from the sigma x sigma equals the minimum. For systematic errors, that x equals that y equals the minimum, we select that equals f from x y, provided that that f from that x that y equals the minimum. To test the proposed method of increasing the reliability of the pattern recognition, computer modeling was performed. The input image in the form of a certain shape and its parameters are selected. For computation, standard objects similar to the input image was adopted, and its parameters were also measured in accordance with the proposed method. After that, using standard formulas for estimating the measure of proximity between the object, for example, Manhattan form, Euclid form, and Campbell form, the main parameters of the measure of proximity between objects are determined. The simulation results are shown in Table 1. In addition, by using a set of different images, an array of data of assessment of measures of proximity between objects was determined, and regression model of the dependence between the main parameters of the assessment of the measure of the proximity between objects were constructed. Regression model is shown in the table 2. The constructed models and table show the effectiveness of the proposed method for increasing the accuracy of estimating the measure of proximity between objects, and as a result, increasing the reliability of pattern recognition. Table 1 shows the result of the measure. Euclid Manhattan and Campbell equation. It's a regression model, table 2. And conclusion, the application of the proposed methodology for minimizing the errors of assessing the state of the object and or process or of the electric power industry by SCADA system will improve the reliability and quality of power supply. This achieves to more accurate diagnosis of the condition of the equipment produced in real time on the equipment of power plant, substation, and power lines. Correct analysis will allow you to receive early warning of the possible network failure, establish the causes of the equipment failures, predict the volume and time of repairs, as well as the equipment service. Thus, it is possible to improve the efficiency of the power system through a stable supply of electricity to the consumer, as well as reduce repair costs by reducing the number of equipment failures. Thanks for your attention.